turn it, leave it, stop, formatting, touch it, bring it, fade, watch it, turn it, leave it, stop, formatting, touch it, bring it, fade, watch it, turn it, leave it, stop, formatting, touch it, bring it, fade, watch it, turn it, leave it, stop, formatting.
All right, class, welcome back. All right, we're going to try to keep this brief, but our goal here is to talk about compounding on a semi-annually, quarterly, monthly, and daily basis. And we're going to use this, we're going to have this conversation in the context of the simple interest formula. So this is going to be the formula that we use, and in later lessons, we're going to talk about a more useful, a more sophisticated formula that can get us to where we want to be. All right, so in having this conversation, we want to remember that we're going to basically be looking at things in the context of how often we're going to be adding or applying the interest in from the standpoint of time. So in a nutshell, if something is in an annual basis, we're basically talking about 12 out of 12 months or a full year. Semi-annual, 6 out of 12 months, 0.5. Compound quarterly, 1 out of 4. Compound monthly, 1 out of 12. Compound daily, 1 out of 365. So we're going to be using those ideas. All right, let's look at our first question. Okay, how much interest does $5,030 earn at a 2.8 interest rate if I am compounding that quarterly, or in other words, in every 3 months? So here's what we're basically looking at. We're looking at principal, the rate, the time, and that's going to give us our interest. My principal is 5,300. My rate is 0.28. That's 2.8%. And I'm compounding 4 times a year, so that's quarterly. So that's 2.5. I multiply that. My number is $37.10. That's the interest that I just earned on a quarterly basis. All right, let's continue. All right. All right, the next problem we have is one in which we have $2,000 that we're earning compounded annually. That means compounded once a year. And in 2 years, what interest would we have if our interest rate is 4.2%? So stay with me on this. Here's my 4.2% converted as a decimal. I'm multiplying that by my principal, and it's annually compounded, so that's 1. So we should get 84, easy peasy. I take my 84, I add that back to my principal, and that gives me 2,084. That's my new balance. Throw that balance here, multiply that by my rate. 1 times 1 because it's annual. There's my new interest after the second month. So this is interest after my first month, interest after my second month, okay? I throw that second interest back into the principal. This is my new balance after 2 months. So according to the balance, after 2 months, I have $2,171.53. And if I earn $84 and $87.53 together, that will give me how I got to 171.53. That's the interest I've earned after 2 years. Let's take a look at our next question. We have Margaret. She is depositing $1,000 in the savings account, and she has a rate of 5.4%. And this is compounded, wait for it, semi-annually. So how should this work? Well, semi-annually is important because we're going to go 0.5 instead of 1. Okay, this is my interest. This is my rate converted as a decimal, and I'm multiplying that by my principal. That gives me $27 in interest. Add my 27 back to my starting principal. So I now have $1,000 and $1,027. Now that $1,027 has to be multiplied again by my rate, 0.5 annually. That's going to give me $27.73. I add that back to my new balance, and my final balance should be $1,054.73. All right, that's my balance after 1 year. All right, and in my next example, I have a guy named Jonathan. Jonathan is depositing $6,000 in a savings account, which is paying at a 3.2% interest rate, compounded quarterly. So now, because it's compounded quarterly, what I'm going to do is I'm going to say 3 divided by 12, which is 1/4. That's 0.25. That's what I want. That 0.25 is being multiplied by my rate, being multiplied by my principal. So my interest is $48. Now stay with me. That $48 is being added back to my original principal. So after quarter one, I have $6,048 in my account. All right, we're going to take that money and reinvest it. All right, here's my rate. Here, this is my time compounded quarterly. I now have $48.30 some odd cents. Add that back together. That gives me a new balance for quarter two. Quarter two is $6,096 and some odd change. Multiply that by my rate. Over time, I now have $48.77 I earn in interest. All right, we're in quarter three now. Quarter three. All right, that interest is added to my new balance. That gives me $6,145 and change. That number is then multiplied by my interest rate over time. Now I've earned $49.16 in interest. That interest, again, one more time, is added back to my balance. And my final balance after 1 year, 4 quarters, is $6,194.32. All right, question 5. Looks like we have $1 million and is being compounded at 5% daily. Ooh, okay, so what does this look like? So when I'm compounding something daily, that's 1 out of 365. Okay. All right. My percentage, that is it in a decimal. My interest is principal times R times T. So that means once I get my math out of the way, I'm earning $136.99 every single day. Wow, wow. That's pretty good. Let's look at my next example. Christian, she is deposited $9,000. My interest rate is 4.1%. Compounded what? Not daily. This time it's monthly. Okay, how much is she earning at the end of the month? Okay, we throw in our values. Here's my principal, here's my rate, here's my time. Multiply those things through. We're going to get $30.75 every month. Not bad. Here's my next example. So now we're going to talk about some more symbolic language. Okay, so Kelly is going to invest D dollars in an account that pays this interest, and it is compounded weekly. Remember, it's compounded weekly. Okay, so we're not talking about 1 out of 31. We're not talking about 1 out of 365. We're talking about 1 out of 52. Compound it weekly. And we want to find her balance algebraically after one week. So what are we doing? Okay, we finding out what the interest is. Voila, this is my interest. D times 0.34 times 1 over 52. And that's, I have to add the interest back to my principal. What did I say my principal was? D dollars. So D plus 0.034D divided by 52 is my 1 day balance. Okay, not hard, but it's, something we got to be mindful of. Okay, number 8, my final problem before we wrap this up. We have Mr. Dolan. He has a rate of 0.17%. Again, 3.7%. Thank you. Well, we know that on December 7th, his principal is 2,000 some odd dollars. He's going to make a withdrawal, all right, and then he's going to make a deposit. Okay, so all of that has changed his balance. So what is his balance right now? Well, we had started here, subtracted 550, added 934, and we also have a subtraction of $300 that I almost missed. Okay. All right, that is now his principal. And I didn't do the math out front, but my calculator does the heavy lifting. There's my rate. Here's time. Okay. And I add these numbers or multiply these numbers together and get an interest of 27 cents or 28 cents. Well, I'm going to add my 28 cents back to my original balance, which was $2,728.08. And that means that in December 7th, my balance is now $2,728 and some odd change. And I'm now going to pay attention to what happens in December 8th. So on December 8th, I take my starting balance, multiply by my rate, by my time. I learn I have 31 cents in interest. Take that 31 cents, add it back to my principal. So my final balance the second day is $2,728.67. Okay, so guys, there's a lot going on in this chapter, and it's really very important that I be candid with you. You have to, you got to practice these, you got to do the problem practice, the practice problems. That's where I want you to transition to right now. Shut this video down. Go get the 3.4 work and try them out. The answer key is posted on the wall in the classroom, or you can use my online resource is there and try to work without looking. And then when you get stuck, pull the answer key out and see where you got had a challenge at. Okay, always guys, rewind the video if something didn't happen the first time and I was talking too fast, but the bottom line is we got to do the practice problems. 30 minutes to study a day keeps bad grades away.